Okay, in the last video, we talked about and looked at some worked examples for average rate of change versus average value. So let's go ahead and look at some non-worked examples that will work together without a calculator. So this first one, what is the average or what is the mean value of this expression, 3t cubed minus t squared over this interval? So we're looking for our average value, and that average value equation, 1 over b minus a, integral from a to b of f of t, in this case our variable is t, dt. So how are we going to work through that? This is going to be 1 over 2 minus negative 1, the integral from negative 1 to 2 of 3t cubed minus t squared. Let's make that look a little bit better here. dt. All right? And 1 over 2 minus negative 1, that's going to be 1/3. And our antiderivative, integral of 3t cubed would be 3t to the 4th over 4. And integral of t squared would be t cubed over 3. And I'm evaluating that from negative 1 to 2. So the average value is going to be 1/3 times, right, 3 times 2 to the 4th power. So that's going to be 3 times 16 all over 4 minus 2 to the 3rd power, 8 over 3. And then I'm going to have minus, right? And if you're not comfortable saying 2 to the 4th power, doing that, it's okay to write your work using parentheses. And in fact, I would encourage you to write your work initially using parentheses so that you are less likely to have an error in your computation. So if this was a free response question, all the right numbers are in all the right places, and this would be a satisfactory answer. If, however, you are having this as a multiple choice question, or you're in an environment that you're expected to simplify, well, we can certainly simplify this work. We're going to have 1/3 multiplied by 16 divided by 4 is 4, so that's going to be 3 times 4 minus 8/3. And then I'm going to have minus 3 to the negative 1 to the 4th power is positive 1, so that's going to be simply 3/4. And negative 1 to the 3rd power is negative, but then another negative here, that's going to be plus 1/3. Okay. And continuing with this, it's going to be 1/3 times 12 minus 8/3 minus 1/3 would be minus 9/3, and then minus 3/4. Well, 12 minus 9/3 is 12 minus 3, which is 9. But 9 times 1/3 is going to be 3, so that's going to be 3. And then 1/3 times negative 3/4 is going to be minus 1/4. And 3 is the same as 12 over 4. So our final answer, if we were going to look to simplify, would be 11 over 4. Okay, so average value of a function. Okay, let's look at our next piece. All right, it's a multiple choice question here. We're told that h is a differentiable function. And we have h given the temperature in degrees Celsius at an Arctic weather station. Which of the following is the best interpretation of h prime of 24? Well, is h prime of 24 the change in temperature on the first day? No, it's not. That change in temperature would be given by the integral from 0 to 24 of h prime of t. Right? That'll give me the change in the temperature. Is it going to be the change in the temperature during the 24th hour? No. If it's going from the 24th hour, the change in temperature there would be the integral from 23 to 24 of h prime of t dt. That would give me the change in temperature. So that's not H prime of 24. Is it the average rate at which temperature changed during the 24 hours? Well, no, the average temperature at which the temperature changed. Well, that would be the temperature at 24 minus the temperature at 23, because that would be my 24th hour if 0 to 1 is the first hour. Then all over the time change, and during the 24th hour, that would be 24 minus 23, and that would be the average rate of the temperature change. So it's not that either. Is it the rate at which temperature is changing during the first day? Well, H prime of 24 is not encompassing the entire first day, but rather we're looking at the rate at which temperature is changing at the end of the 24th hour. That H prime of 24 is an instantaneous rate of change. So we want to be able to discuss and understand those differences. Okay, let's look at one more example. Okay, let's find the average value of the square root of x over the interval from 0 to 2. So average value, right, our formula, 1 over b minus a. If I want the average value of a specific function, so 1 over b minus a, integral from a to b. And I'm going to rewrite this, for right now, f of x. All right, let's go ahead and do our general form first. Right, so that implies that I'm going to have 1 over 2 minus 0, the integral from 0 to 2, and I'm going to rewrite this as x to the 1/2 dx. All right, well, that's going to be 1/2. Antiderivative of x to the 1/2 is to raise the power by 1, but then divide by 3/2, but divide by that exponent. But dividing by 3/2 is the same as multiplying by 2/3. And I'm going to evaluate this from 0 to 2. And so that's going to give me 1/2 times 2/3. And then it's going to be evaluating from 0 to 2. That's going to give me 2 to the 3/2 minus 0 to the 3/2. And if this was a free response question, no need to simplify. But if this is a multiple choice or in your environment you need to simplify, well, we could certainly simplify this. 1/2 times 2/3 is going to be 1/3. And 2 to the 3/2 power is like saying the square root of 2 to the 3rd power. So that would be like saying times the square root of 8. And of course, that does simplify to be 2 square roots of 2, all divided by 3. And for those of you across the pond, that is your SWORD or your simplified radical form. Okay. In another video, we'll look at how we could do some of these average value, average rate of change using a calculator, and we'll also look at some more advanced examples. Thank you very much for your time.